Okay, so hello everyone. I might put this into two videos because I don't like to go over 15 minutes on a video. But I want to get started after you look over the two videos, I want you to then go and take the quiz, and by the time you look at the video, I should have provided instructions, emailed you all instructions on where to take the quiz and things of that nature. So again, remember, we won't be having class on Friday the 16th or Monday the 19th. I believe that's a Monday. But I will be back. And so we will be back in session on the Wednesday the 21st. And I'll probably come in that Tuesday, I don't know yet, and hold some extra hours. But if not, maybe Wednesday and Thursday, I'll stay a little later to hold some more hours. But anyways, you have the book, you have WebAssign and their tutorials and things to look at. So let's just get started. So this is section 1.6. So we're moving on from the exam, and section 1.6 deals. Okay, so sometimes too, in terms of the video, I'm going to write out stuff already in advance and then go over it just because to save space and time on the videos. But what I would advise you to do is pause the video, write everything down, and go back over it. Or you might even want to try the problem yourself if you think you know how to do it. So in example one, and because I don't have room at the bottom, I can't scroll down on this one. So I kind of squoze everything in here, but feel free to use all the space you have in your notes. So again, remember that f of x equals ax plus b. That's the linear function. That's the general function for a linear function. And so example one is write the linear function f of 1 equals -2 and f of 4 equals 0. So given those two values exist in your function, write the linear function. So basically we have 2 points, right? And so since we have 2 points, we can find the slope, we can find the y-intercept. And so here's the 2 points. If we wrote them as an ordered pair, they would look like 1, -2. That coincides to that first imp value we have. And then 4, 0 corresponds to the second. And so then we can find the slope here. Again, if you need to, you can, let's see, you can label your function values as x1, y1 and x2, y2, and then use the slope. Of course, m is the same as a, but if you're used to using m to define slope, then you can call it m, and then just make sure you replace that. You make sure you know that's the same as a. Okay, and then so once you do the slope, and make sure you check my work because I could make mistakes doing these videos, so make sure you double check my algebra and arithmetic. But once we do that, the slope is equal to 1/2. So then we go back and put it in our function. F of x equals 1/2 x plus b. And then we still have to solve for b. So right here is where I solve for b. And you do that by taking one of the points that you're given and plugging it back into your equation. And if you're given a point where 0 is one of your either your x or your y coordinates, I will use that point. Although if you use this point here, you're still going to get the same answer, so you can use that point as well. All right, so 0 equals 1/2 of times 4 plus b, and so you guys can make sure and double check again to make sure b is going to equal to 2. And so then we have our linear function there, f of x equals 1/2 x minus 2. Okay, so if you want, you can stop the video and write this stuff down and then replay it because we're going to go over this now. So there are, again, special types of functions that you should put to memory, their graphs, and know about the certain characteristics of their graph. So we're actually going to look at, so there's special types of linear functions. We're going to look at that last. Let's look at example 2 first, and then we'll come back to the special types of linear function. So we have our squaring function, which we should be familiar with, f of x equals x squared. And just some features. Number 1, it has a U shape. As you all know, it's a parabola. 2, the domain of the function is the set of all real numbers. 3, the range of the function is the set of all non-negative real numbers. That's meaning from 0 to infinity when we say non-negative. The function is even. Remember, and I think, yeah, you guys had it on your exam, to determine whether it's even or not, you evaluate f of -x, and if it comes back the original expression, then it's even. So the squaring function is even. It has an intercept at 0, 0. It's decreasing on the interval negative infinity to 0 and 0 to infinity, and the graph is symmetric with respect to the y-axis. So here's the graph right here of f of x, and it has number 8, it has a relative minimum at 0, 0 as well. Remember, we talked about that in class. So that's the graph, and you can go back and look at the characteristics again and see that it matches with what we just said. All right, so now it's two types, special types of linear functions, and one is called the constant function, and it's one of the most simplest functions, linear functions ever, because it's just a horizontal line, and the general format is f of x equals c, where c is some constant. And so in the example here, this is f of x equals 3, right? So it's just a horizontal line through y, f of x equals 3, which is the same as y equals 3, right? But it's x, because that's your x-axis, and this is your f of x-axis, or your y, okay? The identity function is another common function, and that function is f of x equals x. All right, so your input and your output are the same values. And you can see here, I plotted just 3 points, but 0, 0, 1, 1, negative 1, negative 1. All right, so whatever you put in, the coordinates will be the same, okay? And I think that was one of the questions from your exam as well, about the coordinates that's below the axis 3 units, and it has the same y coordinate, I think, something like that. So that would be considered, that point would lie on our identity function, okay? All right, so the next example of one of the main functions that we talk about is g of x equals x cubed. This is called the cubic. Let me go back to red because yellow is sort of too light. Oh, no, I'll stay, okay. This is called the cubic function, and so the domain of the function is a set of all real numbers, and we're going to see a picture below in a minute. Actually, this is a picture, so maybe I'll give you a chance. So pause it if you need to and draw this picture, and then we'll go back and look at the characteristics. So the domain, so you might have to pause the video. The domain of the function is a set of all real numbers. The range is a set of all real numbers. This function is odd. It has an intercept as 0, 0. It's increasing everywhere. Because remember, you read a graph from left to right. So if you follow that curve, it's steady going up. And it's symmetric with respect to the origin, okay? And if you were to put a mirror sort of diagonal at the origin, then it would mirror what's on the other side, okay? So that's a cubic function characteristics. And again, that's how it looks. This is, I'm gonna go back to that previous page if you didn't get it, but I want you to take a chance or take time and draw this graph first. And then let's look at the characteristics here. So this is what we call the square root function. Okay, so square root. And the characteristics for the square root function, as you can see from the graph, the domain of the function is a set of all non-negative real numbers. The range of the function is a set of all non-negative real numbers. And I'm just giving you interval notation, so you can either say it in words, but I may and probably will ask you for interval notation. And so you need to become familiar with interval notation. All right. The graph has an intercept at 0, 0, as you can see, and it's increasing on the interval 0 to infinity. And again, when we talk about increasing, decreasing, or constant, we never put brackets on our intervals. And there we have it again. And I'm going to give you a chance to draw that function. So, okay, let's go back. Sorry, I had a little delay. Okay, so this function here, do we call it the inverse function? The reciprocal. This is the reciprocal function. And so, yeah, this is the reciprocal. Okay. Just making sure in my head. All right. So the domain of the function is all reals except 0, as you can see, and there is actually what we call, and we're going to talk about this later in the class, but to give you a heads up, there's an asymptote at x equals 0, the line x equals 0, and the line y equals 0. We're going to talk more about that later on in the class. The range is again all reals except for 0, so there's the notation there. The function is odd. The graph does not have any intercepts because of the asymptotes. It doesn't cross the x or the y-axis, but we'll talk more about that later. And the graph is decreasing on the intervals negative to infinity to 0 and 0 to infinity. And it is symmetric to the origin, with respect to the origin. All right, so this is the reciprocal function. It's another function. So all these functions and the graph of these functions you need to put to memory if you're making note cards for this class, which I would highly advise you to do. You need to put these on note cards so you know the shape and know their characteristics, okay? And the last type, so the last thing we're doing in this section, and then we'll be done, so hopefully in a few minutes I'll be done with this video and post the 1.7 video, which, you know, you have a chance to look at that later, or if you're doing it all at once, good for you. All right, so this last example is what's defined as a piecewise defined function. Now, we talked about piecewise functions, and you actually had one on your exam, and so I didn't draw the piecewise function yet, but to graph a piecewise defined function, you graph each equation separately over the specified interval, okay? And so here we see we have two functions on our piecewise functions, and the number that sort of breaks them apart is important, and in this case it's 1, right? And so that number 1 separates, so just sort of note that when x is equal to 1, the functions separate, right? And so it's important to know that. It's also important to know where does 1 belong with either the first function or the second function. And in this case, it belongs where? With the first function, right? Because that less than or equal to, that less than or equal to sign. Okay, and so because these are both lines, all we need is 2 points on that line, on those lines, to graph it, right? All right, and so when we draw a picture, the first function will represent be represented in red, and the second function will be represented in blue. And so I just so you pick any x values, and then you have to find the y value, but you have the function, so you're fine. So I just picked, and I keep it simple, so I always pick 0 if 0's, you know, wherever 0 is one of my options. And so 0 is one of the options, just looking at this top function. But look at that top function. It's 2x plus 3 for all x less than or equal to 1. So 0 is less than or equal to 1. So 0 would be with the red function. And if I plug in f of 0 into 2x plus 3, I get 3, right? I didn't write that there. Feel free to put that in your notes so you have it. But for the sake of time, I didn't want to write everything. Okay, and then I use 1 because 1 is also, although 1 is our special function number that separates our function, 1 is part of that first function, right? Because it's less than or equal to 1. And so f of 1, when you plug 1 into that function, it's 2 times 1 plus 3, so f of 1 is 5. So therefore, we have the points 0, 3, and 1, 5, and therefore, since we have 2 points, we can draw our graph. For the blue function, we need to find values that are greater than, strictly greater than 1. Well, 2 and 3. Like I said, keep it simple, right? So when x is 2, plugging in, so this would be negative 2 plus 4, so y is 2. So that's the point 2, 2. And then when x is 3, we have negative 3 plus 4, and so that's the point 3, 1. Okay. And so now, but here's the thing, and this is where it may get a little, hopefully I don't want to confuse you, but the beauty of having this video is you can listen to this over and over again, right? Okay, let me hurry up because I'm trying to get under 15 minutes. Okay, so that 1, even though it's not on the blue function, right, we need that to know if 1 was on the blue function, where would it be? And we need to know that because on our graph, we will have what we call an open circle at f of 1 for the blue function. And I'm sorry I can't scroll down on here. So look at that. So if we were to plug in f of 1 into that function, where would it be? It would be f of 1 on that function would equal what? 3, right? So that means there's an open circle at 1, 3. Okay, so let me write, so open circle, and I'm a little over 15 minutes, but I promise you we're almost done, at 1, 3. Okay, so now we have everything to plot. So I'm going to plot my red function in red, my points. So let's look, I'm going to plot, so we have the point 0, 3, and 1, 5. Oh, sorry. And 1, 5. And this, oh, so I should say, this green dotted line I drew, this is an invisible fence. And this is not part of your graph. So if you draw it, when you're doing a piecewise function, I know that it's not part of your actual graph, but you're doing it to help you divide your piecewise function. But when we get further and talk about asymptotes, you're going to have to take that off. But it's really nice because think of the two functions and the two values. Think of it as a neighborhood. And the line, that line, x equals 1 right here, this represents an invisible fence that's dividing the people that live on the street. So if you're on the left side of that fence, then you're in the red neighborhood. Okay, but if you're on the right side of the fence, you're in the blue neighborhood. And our points again for the blue was 2, 2 and 1, 3. I'm sorry, and 3, 1. 3, 1. And we had so this is why the open circle is needed. If we just, oh no, that's not. If we just were to plot this graph here, we would have an entire values between 0 and 1. I mean, between 1 and 2 wouldn't go anywhere. But we want every value to go somewhere, right? Because look at that. Every value should be accounted for. So that's why we need that open circle. So there's an open circle at 1, 3. So at 1, 3, we have an open circle, and then we can connect that. So now these points right here have somewhere to go. They go somewhere. They're on that blue function. All right, they're in the blue neighborhood. You have to, oh, I didn't mean to do like Bloods and Crips. Don't think of it as a gang member. They're not gangs. Just think of it as, I don't know. I just realized. Okay, I'm sorry. Let me digress. All right. So anyways, let me stop this because I went over my time and I have to start the other video. But go back over this if you need to. Go back over the notes, and then you should be able to do the homework from this section after looking at this video. All right. Bye.